Today we are going to discuss different ways and methods of measurement. Direct method of measurement and indirect method of measurement. These will include how we can find the height of an accessible object or an inaccessible object. Also, how we can find the size of moon or a nearby planet. How can we measure the distance of a nearby planet or moon? How we can find the distance of a star. We'll also discuss what are the radar and sonar method of measurement. And finally, we'll go for measurement of the small distances. Measurement of the small distances will include estimation of atomic size by Avogadro method, how we can measure the size of oleic acid molecule. So all these we'll be discussing in today's discussion. Let's suppose we want to measure the distance in day-to-day life. For that, meter scale is a sufficient instrument for taking measurement. And with the meter scale, whose least count is 1 millimeter, we can take measurement in day-to-day life. And that is the direct method of measurement. With the vernier caliper, we can measure up to 0.1 millimeter of accuracy. And when we are using a screw gauge, in that case, it can be measured up to 0.01 millimeter of accuracy. So these will be the one which we use for taking direct measurement. But many times we'll come across the things which we want to measure, which cannot be measured by just normal scale there for measurement. So we use some indirect methods of taking measurement. Suppose we want to measure the height of an accessible object. It may be height of a tree. It may be height of an electric pole. So all these we can take help by the method which we are going to discuss, where we can find the height of an accessible object. Suppose we want to measure the height of an accessible object. It may be the height of a tree. It may be height of an electric pole. So suppose this AB represents accessible object and its height is HV, which we want to measure. So for that, we'll take help of the trigonometry, and what we do, we take observation from a point P, which is at a distance D from the foot of this object. So suppose the angle subtended by this object at the point P is theta. So obviously, in triangle ABP, if we can take tan theta equals to H by D, or H we can write D into tan theta. This angle we can measure with the help of the instruments, and we can find out what is the angle subtended by this object at the point P. Then from the trigonometrical table, we can find out what is the value of that tan theta, that particular angle theta, and D is the distance from where we have taken measurement. So after substituting in the formula D into tan theta, we can get the height of H. So this is how we can measure the height of an accessible object. If you want to measure the height of an inaccessible object may be like we want to measure the height of a hill, or we want to measure the height of a tree which is on the other side of a river without crossing the river. It may be the height of a building which is on the other side of a busy road, so without stopping the traffic there. Because for such cases, we cannot go up to the base of the object there. Like if suppose it is the hill, we cannot go up to the point B. Due to its construction, we can maximum go up to this point. But we want to measure the height AB, which is H. So this distance, as we cannot go up to this point, so what we do, we take measurement from 2 points which are separated by a specific separation. We take measurement from the point P and Q, which are d distance apart, and the angle subtended there is θ1 and θ2. And suppose this distance B and P is x. We do not know the value of this x because we can maximum go up to this point. So what we do, again, if you take the triangle, now we take suppose the triangle ABP. So in triangle ABP, tan θ1, that is your h by x, and with this we get x by h equals to cot θ1, or x equals to h cot θ1. Suppose I call this as equation number 1. And if now we take the triangle ABQ, so in triangle ABQ, tan θ2 is h by d plus x. It will be h by d plus x. So this is your d plus x by h cot θ2, or d plus x equals to h cot θ2. This is the second one. Now from equation 2 minus equation 1, from second equation, if we subtract first equation, x will get cancelled. So we have d plus x minus x equals to h cot θ2 minus cot θ1. X will get cancelled. So we'll have from here h equals to d by cot θ2 minus cot θ1. So using this formula, we can find out the height of inaccessible object. So d we have already taken, that is the separation between the point P and Q. Cot θ1, cot θ2 we can find out, and then from the formula we can get height h. Now you can see this x, which we cannot measure, is not coming up in the final result. So as it has been already eliminated by simplification, so obviously as x is not there, whatever things are there, we can easily measure them and we can find the value of h. That is the height of an inaccessible object. Suppose we want to measure size of moon or any nearby planet. So for that, what we do, suppose we have to measure the size of the moon. So we'll observe it from any point on Earth. Say it is P, and we take observation of its diametrically opposite points. And we see what angle its diameter is making at the point P. Suppose the diameter of the moon is d, and we have taken measurement from the point P where it is subtending an angle theta, and r is the distance of the moon from the point P. So here, for this angle theta, we can take angle which is arc by radius. So this is your arc AB divided by this distance AP or BP, that is r. Now, as they will be subtending very small angle, so for a small angle theta, so for a small theta, arc AB will be nearly equals to AB. This arc will be nearly equals to the chord. And remember, this arc, this one we are taking as the arc, means this is the arc for which this arc, that is AP or BP, is radius. It is not this one. So for the radius r, or for the distance r which we are taking as radius, this is the arc. So this is your AB, and this AB we have already taken that it is d. So theta will be nearly equals to d by r, or d is nearly equals to r into theta. So if you know what is the distance between the moon and the point of observation, or say from Earth, and what is the angle subtended, we can find the size of the moon or any nearby planet. Now suppose we want to measure distance of moon or any nearby planet. So for that, this is suppose the point whose the distance we want to measure. This may be the moon or nearby planet. We observe this one from 2 points on Earth's surface. Say it is A and B, which are d distance apart. This is also called as a parallax, because you are observing the same object from 2 different directions there. Okay. So here, this is A and this is B, where the angle subtended is theta. So again, if you take as theta will be equal to arc AB by the distance r, which is basically the radius for this arc AB. For a small theta, again as the arc AB will be nearly equals to AB, and that is d. So this time theta will be nearly equals to d by r, or r is nearly equals to d by theta. So d is the distance between the point A and B from where we have taken measurement, and theta is the angle subtended. So substituting in the formula, we can get the value of the distance r. But suppose instead of this moon or nearby planet, if you want to measure the distance of a star or far off a star, so for that, if you take distant star, it will be subtending angle at the point A and B, which will be small, because if the point P is here, angle is suppose theta. If I take observation for this particular point, the angle will be small. And if the angle is small, in that case, we cannot measure it very accurately. So for that, we want the angle to be large. So for that, what we can do? We can increase the separation between A and B. That means we can take observations from 2 points which are relatively large at larger distance. So maximum distance between 2 points on Earth's surface will be the diametrically opposite point of Earth. So we can take measurement from there. But the thing is, even if we take observation from diametrically opposite points on Earth's surface, the distance of the star is so large that the angle subtended will still be very small, which we cannot measure very accurately. So for that, we use slightly different method. Instead of taking the measurement from diametrically opposite points on Earth's surface or from 2 different points on Earth's surface, we take observations from diametrically opposite point of Earth's orbit around the Sun. Suppose S is the star whose distance we want to measure. So this star S is observed from 2 diametrically opposite points of Earth's orbit around the Sun. This is suppose the orbit of the Earth around the Sun. So we have taken observation from E1 and E2. And S dash represents a far off star, a star which is at very large distance. So if the star which we are taking as a reference is at very large distance, so these, if they are observed from E1 and E2, these will be almost going parallel. Because as it is at very large distance, it will just appear as if they are going to meet at that point. So these will be the reference lines of observation of the far off star. In respect to that, we take observation for the star whose distance we want to measure. So suppose it subtends an angle theta 1 and theta 2 at the star S when it is observed from point E1 and E2. So again, if you take for the angle theta 1 and theta 2, so theta 1 plus theta 2, this will be equal to arc E1 E2 by the distance r, because the total angle here will be theta 1 plus theta 2. Again, for a small theta 1 and theta 2, remember, even if we are observing it from diametrically opposite points on Earth's orbit, angle is still small. It is large in respect to the extent that we can take observations properly. But still it is a very small angle. So as theta 1 and theta 2 are small, so arc E1 E2 will be nearly equals to E1 E2. That is the distance between E1 and E2. So this will give theta 1 plus theta 2 nearly equals to E1 E2 by r. Or we can write r equals to E1 E2 divided by theta 1 plus theta 2. E1 and E2, these are distance between diametrically opposite points of Earth in its orbit around the Sun, and the distance between the Earth and Sun, that we take it as 1 astronomical unit, so it is just like the 2 astronomical unit distance divided by the angle subtended. So substituting in the formula, we can get the distance r. That is the distance of the star from Earth. How we can get diametrically opposite points of Earth's orbit around the Sun? As we know that Earth completes its revolution around the Sun in 1 year. So if you are taking a gap of 6 months, then Earth will be at diametrically opposite point. Because in 1 year it is completing 1 revolution, so obviously in 6 months it will be at diametrically opposite point. So we take observations from E1 and E2 after a gap of 6 months. So we measure the angle in respect to the distant star S dash after a gap of 6 months, and then we can measure the distance of the star. For measurement of the distances, there are 2 more methods there, that is radar and sonar. And these are based on echo principle. That is, we send the wave, it gets reflected from the obstacle, we receive those signals, we find out what is the time lag between the two, that is in the transmission and reception. We know what is the speed of that wave. So from that we can find out the distance of the obstacle. So if you take radar method, radar is basically radio amplification, detection and ranging. So what is done? From Earth station, we send radio waves. Radio waves get reflected from ionosphere. So they are received back at the Earth station after a particular duration of time. Now, suppose any unwanted object enters in that region, these will get radio waves will get reflected from those objects and they will be received at the Earth station. So we can find out what is the time lag between the transmission and reception of such radio waves in that case. What is the time lag? What is the time lag between the transmission and reception of radio waves in that case? And as we know the speed of radio waves, we can find out the height of those obstacles. Suppose this is the unwanted object at a height h, and we are sending radio waves from here. So h is the height of obstacle, and t is time lag between transmission and reception of reception of radio waves. That means the time gap between the transmission and the reception of those radio waves, we are taking it as t. So here the total distance traveled by radio waves, that will be equals to h plus h. So as total distance traveled by radio waves, this is equals to 2h, and the time lag is t. So speed of radio wave this will be equals to 2h by t, and all electromagnetic waves in space or in vacuum, they travel with the speed of light. So this radio wave, as it is also an electromagnetic wave, so its speed will be c. This is your 2h by t, and 2h is your c into t, and that implies h is equals to c into t by 2. So using this formula, we can find out what is the height of the obstacle. So we can know that in any restricted area, at what height any unwanted object is there. So this is based on the echo principle. But of course, do remember that what we have discussed is just a very basic principle behind the design of the radar system there. In fact, the actual equipments which are used there, they are very sophisticated, because it is not just sufficient to know that any particular unwanted object is there in any restricted area at this particular height. If it has been noticed, in that case there should be some measure or some arrangement so that we can restrict that or we can counter that. So for that, we should know that with what speed it is moving, in which direction it is moving. So those radar equipments are basically the advanced one, where all such parameters can easily be measured there. But basic principle behind the radar system is the echo principle, and we use this one to measure the height of the obstacle. This is another one which is based on the echo principle. Sonar, that is the sound navigation and ranging. Now in this one, we send ultrasonic waves to find position of any unwanted object. Suppose it is the sea there, or in ocean there is any unwanted object, or we want to search for any particular object there. So for that, suppose this is the ship on which we have the sonar equipments. So from that, we'll be sending the ultrasonic waves. These ultrasonic waves, they will get reflected from the seabed. But if there is any obstacle, say this is a submarine there at a particular depth t. So those ultrasonic waves will get reflected from these submarine, and they will be received after a particular duration of time. So we measure what is the time lag between the transmission and the reception of ultrasonic waves, and we know that this distance will be 2d. Speed of the ultrasonic waves is already known, so we can find out the position of such obstacle. So again here, if you consider the total distance traveled will be 2d by the ultrasonic waves, and if I assume that t is the time lag between the transmission and reception of the signal, in that case this 2d by c by t will be equal to speed of ultrasonic wave. So suppose if you represent it by v, it is your 2d by t, and that shows that 2d is v into t, or d equals to v into t by 2. So with this, we can find out what is the position of the obstacle there, or if you want to search for any other object. Suppose there is a ship which has sank in the sea and we want to know its position. So we can use this sonar method to know for its position. So far we have discussed the distances which we have measured. They were the large distances, like the distance of accessible object, inaccessible object, distance of nearby planet, distance of star. So all these were the large distances. If you want to measure small distances, like for day-to-day life also, if you have to measure the distances or the length or anything which is of a smaller scale, we can take help of the vernier and caliper. But with that we can go only up to say 0.01 millimeter accuracy. But suppose we want to measure the size of atom, or we want to know what is the size, if you want to know the size of an atom or size of a molecule. So for that, some methods are there by which we can estimate the size of the atom or molecule. So Avogadro has given one method by which we can estimate the size of an atom. It is the estimation, not the measurement. You can know what should be the order of magnitude of the size of the atom. So for that, what we do, we take a small amount of the substance. Suppose m is the mass of the substance taken and its atomic weight is A. So it is the mass of the substance taken. A is its atomic weight. A is atomic weight. Therefore, number of moles taken, that will be equals to m by A. So if we know that number of moles, we can tell what is the number of atoms there. So number of atoms taken, that will be equals to m by A into n, where this n is Avogadro's number. So we know how many atoms we have taken. Now let's assume that let R be radius of each atom. If R is the radius of each atom, then the volume of each atom, this is equals to 4 by 3 pi r cube. Now we know that we have taken this much number of atoms, m by A into n. So we can see how many, what is the volume of the substance taken there, or what is the volume of the atoms which we have taken. So the volume, total volume of all atoms, this will be equals to m by A into n into 4 by 3 pi r cube. And suppose that rho is the density of that substance taken. If rho is density of substance taken, if rho is the density of the substance taken, then volume of the substance taken, this is equals to m by rho. So we know what is the volume of the substance taken. Now Avogadro has said that the actual volume occupied by the atoms is 2/3 the volume occupied by the substance. Actual volume occupied by all the atoms of the substance taken is 2/3 the volume of the substance taken. So according to Avogadro, volume of the total volume of the atom, that is your m by a n into 4 by 3 pi r cube. This is 2/3 volume of the substance taken. So here we can cancel m, we can cancel 3, we can cancel 2, and that will give r cube equals to a by 2 pi n rho. 2 pi n rho. This is your r cube. So r will be your a by 2 pi n rho power 1 by 3. So this will give the radius of the atom taken, where a is the atomic weight we know for the substance, n is the Avogadro number, rho is its density of the substance which we have taken. So by substituting in the formula, we can know what is the size of the atom. But of course, this is the just estimation of the size of the atom. Suppose we want to estimate the size of oleic acid molecule. Last one which we have done, where we have estimated the size of an atom. Now this time we want to take the method where we can estimate the molecular size. So we want to measure the molecular size of oleic acid. So for that, what we do, we take a standard solution of oleic acid in alcohol. The strength of oleic acid in alcohol solution be having a strength 1 by 500. It means out of 500 cc of that solution, oleic acid will be 1 cc. Suppose this is a container in which we have water there. It is a container of large surface area, and in that we put few drops of oleic acid solution. So it will spread over its surface. So those will just spread over its surface, and suppose it is spread like this. We just leave them for few hours undisturbed, so that alcohol gets evaporated, and now on the surface of water you have a film of oleic acid left. We measure the area of the film by using a tracing paper there or a graph paper, and we find out what is the thickness of that film. The thickness of that film will be nearly equal to, or it will be equal to, molecular size of oleic acid if the film is a monomolecular layer. How to ensure that it is forming a monomolecular layer? We will take few drops of the solution, we'll put on a container containing water and having a large surface area, and once alcohol gets evaporated, it will be confined to a very small area, and that will ensure that it has a monomolecular layer. So suppose we take n drops of solution, each of volume V. We have taken n drops of solution, each of volume V. So the volume of it taken, this is oleic acid, so we are taking n drops of the solution, each of volume V, and we put it on the container containing water. So the volume of the oleic acid solution taken will be n into V, because we have n drops, each of volume V. Now volume of oleic acid taken, that will be your NV into 1 by 500, because the strength we have taken 1 by 500. This is the strength of oleic acid solution in alcohol. And now let A be area of oleic acid film and T be its thickness. Therefore, volume of oleic acid film, that will be your A into T, and this is also giving you the volume of the oleic acid taken. Therefore, A into T is equals to NV by 500, and that implies T is equals to NV by 500 A. This is the thickness of oleic acid film, and as it forms a monomolecular layer, therefore this thickness will be also equal to the molecular size of oleic acid. Suppose this is a container in which we have marble balls kept there. So you can see we have so many marble balls forming different layers. Now, and there are say 4 layers of the marble balls. If I take the marble balls of this container and I pour it in the room, they will spread over its surface. And now how many layers they will form? They will form single layer, because they will just get scattered in the room. Suppose we go on adding marble balls, they will spread over its surface of the room. They will spread over the surface of the room. Second layer of the marble balls will only start when the entire surface area of the room gets filled completely. Because when you have suppose 2 marble balls and you are putting a third one, it will displace these 2 and it will take position in between. But if suppose they have occupied the entire surface area, and now if you are putting any marble ball, it cannot displace these 2. So when entire surface is completely filled with the marble balls, then if you are putting any marble ball, it cannot displace the marble balls below it. So then it will form a second layer. So second layer will start taking place. So it will be formed only when the entire surface have been filled singly. In the same way, here we have a container having large surface area. There we have the water. We have taken only few drops of the solution and we have poured on its surface. So it will spread over the surface of water. As it will spread over the surface of water, since it is few drops, definitely it is not going to occupy the entire one. Even if it occupies, since our strength is 1 by 500, it means out of 500 cc of the solution taken, oleic acid is only 1 cc. So once the alcohol gets evaporated, then surface area of that, or the volume first of all, will also get reduced to a large extent, and the surface area will also get confined to a very small area. So in that case, it will just ensure that it is not occupying the entire surface area of the water surface there, and it is confined to a very small part. So definitely it is a monomolecular layer. So we measure the thickness of that oleic acid film. As it is forming a single layer there, obviously that thickness will be numerically equal to the molecular size of oleic acid. Another thing is there, the film which will be there, it will be of irregular shape. So if it is of irregular shape, how will you measure its area? So for that, we take help of the tracing paper and graph paper. So we put the tracing paper over it, and then we mark its outline, and then we put it on the graph paper to know what is the area enclosed by this surface. So with that, we can measure the area of the film. And once you know the area of the film, substituting in the formula, you can get the thickness of the oleic acid film, which will give you the size of the oleic acid molecule.